And I'm going to do, I wish I didn't have these axes here, but I'll do 0 to 2 pi. So we'll put pi here and 2 pi here. So just my cosine curve with an amplitude of 3. Oh, yeah. Sorry. I was like, wait a minute, that's not going to work out right. 2 pi, 3, negative 3. We'll just do one period worth to start. Okay, and so when you insert your asymptotes at your zeros, and then we'll work on just in between these two asymptotes. In light of the fact that it was a reciprocal function, because this y coordinate was negative 3, we talked, oh, you reciprocate that and you get negative 1/3, which if you then did it that way and checked your answer in the back of the book, it actually wasn't right. So I haven't spent too much time thinking about this on paper, so let's think this through. So y at pi, what we're going to find out is it does just reflect off the minimum. So it's actually going to be easier to graph. You're not going to have to reciprocate that value. If that minimum's at 3, then when you reciprocate it, it's going to be a maximum at negative 3 there, a relative maximum at negative 3 still. So we're not going to have to reciprocate that value, but why? So if I go back to kind of the basics of graphing, when you first started graphing in 8th grade, 7th grade, you did it with a table of values. So if I think about this, and we know that this relative minimum, soon to be relative maximum, is occurring at pi, if I actually plug in a pi, 3 times the secant of pi, so the pi is my x-coordinate, trying to come up with the y-coordinate, that's 3 times 1 over the cosine of pi. The reason we don't reciprocate I've finally realized, the reason we don't reciprocate the 3 is because the reciprocation happens prior to that vertical stretch. Do we follow that? So if you're going through order of operations, you're going to do 1 over the cosine of pi first. And what's the cosine of pi? Pi's over here. This is negative 1, 0. Negative 1. No, you didn't have to memorize it, but it is one of your quadrantal angles, so you should just think of your coordinates at the end of that. So the cosine is your x-coordinate, so negative 1. So it's 3 times 1 over negative 1, and 3 times negative 1 makes it negative 3. So the point on your graph is actually going to still be pi negative 3, because the reciprocation happened earlier, and then we multiply that by 3. Does this make sense? Okay, so visually that's going to make your life easier, because whatever your minimum was of your guide graph is going to become the maximum of your secant graph when you sort of reflect it. Let me draw in one more cycle going this way, negative pi, negative 2 pi. A couple more asymptotes. And I'm definitely just sketching this. And then I'm going to get rid of my guide. I'll still be able to see it because my eraser isn't the best, but that's good. I do want to see it, so that one's there. If you're in between these two asymptotes, you're just going to bounce off your maximum. So the takeaway there, I guess, is that your and your actual graph really won't ever intersect or overlap other than barely touching and being tangent to each other right there. Does that make sense? So, I mean, it is a reciprocal function. I reciprocated the final value, and I shouldn't have done that. We reciprocate in here, and then your final value gets multiplied by 3. Correct. Correct. And when we flip it now, we're just flipping it over the minimum. So I clearly misremembered that from last year, and then I thought about it, and it finally makes sense to me why you don't reciprocate at the very end, because the reciprocation happens midway through the problem, and then you multiply that answer by 3. Say that. So give me an example. What would I be asked to graph? 3 cosine of pi x. If I were just graphing that, I would just straight up graph that. I don't think they would ever do that. If you want the secant relative to that, you would just graph this. If they were, what they would technically be asking you would be to graph the secant of pi x, 3 times the secant of pi x. And still you would graph this, and then you would just bounce off your maxes and mins. Okay? Yep. Yep, you're always moving forward. You're always, so it's a simpler way of doing it. Obviously, it actually makes it easier, I think, because you don't have to think about the reciprocal. I just kind of wanted to show you why that happened and why, from an algebraic standpoint, that should make sense. We do get the value of -3 at pi. Stephen. Or do it dotted, because otherwise, yeah, otherwise you'd have something that fails a vertical line test technically. Okay. So from there, I also want to, something that came up on your homework last night. Adam, I'm going to get rid of what you just had me brainstorming about. I want to graph 40, well, this is going to be number 46 out of the textbook. You can write this down. It's, just kidding, I don't want to do that one. I want to do 48. Which is y equals a cosecant of 2x minus pi over 2 plus 1. Because we never got to a vertical shift yesterday and where that's going to fall in the order of how we do this. Okay? Obviously the secant, or the sine guide is y equals sine of all of this. So the vertical shift is always the last thing that happens. Can we agree with that? Order of operations, order of transformations. The vertical shift up 1 is always the last thing that's going to happen. So in order to graph this, we're going to graph this first and then shift it all up 1. So as far as using our guide, we're going to graph this first, turn it into the cosecant function, and then shift everything up 1 at the very, very end. Does that make sense? Okay? Jalen. Let's address that at the end because I think it should still be the midline. What do you mean? Yeah, we could do it that way. I'm going to do it kind of following the order of transformations, and I'm going to worry about the +1 at the end. But you could start with your midline and kind of treat that as your x-axis. That you can, yes. Okay. I'm going to show this a little bit differently just based on the order of transformations. So I'm going to graph this first, based just on this. And then once I graph this, I'm going to shift everything up 1. Okay? So sine of 2x minus pi over 2, I've got to factor out my 2. That's going to be my guide. So everything gets shifted pi over 4. What's my period? Okay? So I'm going to count by pi's over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. 5, 6, 7, 8 pi over 4. We'll be slightly off the graph. I really wish I didn't have those y-axes right down the middle, but that's okay. So my sine graph is going to start at pi over 4 units to the right, and it's going to end pi units after that, right here. And then my midline's there. I've got an amplitude of just 1. I'll go every other as 1 so it's not as crammed. So there's my guide. I would put in my asymptotes. I'll just do this 1 cycle worth. And I would bounce off the relative maxes and mins. Does this make sense? Yep, we're going to do that. So I would get rid of my guide. And then shift the entire graph up 1. So this parabola, rather than being at pi over 2, 1, is going to be at pi over 2, 2. Remember, my scale, by the way, is counting by. And then this one here, which has a maximum at -1, is going to be shifted up 1, and it's going to have a maximum at 0. So then I've shifted everything up 1. And so, Jalen, to your point, 1 is still my quote-unquote midline. Yeah. Yes. So are there any questions on that technique? Graphing this first based on this as a guide, and then shifting your final graph up 1. Does that make sense? Any questions on that? What Jalen is saying is this: if we have the same function, I'm just going to do it a different way. She's saying my midline is 1. So she's going to draw a dotted line in at 1 and treat this as her x-axis. I'm putting it in quotation marks because it's not truly my x-axis, right? Make sure, and this is what happens sometimes when people do that, and this is not a huge deal, but just make sure when you're scaling, you're still scaling your true x-axis, not your new frame of reference x-axis. Does that make sense? So I'm still going to kind of shift everything pi over 4. So this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And so now when I start my sine curve, I'm going to start at, see, this is where this is going to be troubling now. Let's see if this comes up. Maybe I lied to you. Maybe you cancel this. I got to think through this. Pi over 4 starts there. So your cycle ends there. 0. We're going to go up 1 and down 1. Oh, no, yeah, it will work. Yep. And then you're still going to bounce off right there. So here's the quick thing though. Once you have your sine graph on here, your asymptotes don't go at your zeros of that graph. They go at your kind of new zeros based on the midline. So we're still going to put our asymptotes there, and there based on the idea that our midline is now being treated as our x-axis, and then bounce right there. And it is the same graph. So the only thing and I'm glad we went through both ways, because I want to make sure that you're not putting your asymptotes at the true zero of your sine graph, because your sine graph was already shifted. It goes on where your traditional zeros would be. So treat your zeros as if it's where it crosses the midline, and you get the same thing. Any questions on that? So two different ways of thinking about the same graph. Okay? Any questions on either of those two with the shift? So other questions on your homework. What else on your homework? What'd you say? Okay, 53. Okay, 53 was a composition. So when you do f of h of x, Connor, what equation did you write?
1 over cosine of...
Before that. F of h of x, just using f of x up here and using h of x. Good. Okay, so that was step number 1, was coming up with the f of h of x. So once we have that, and I'll bring this transferred over to a graph, y equals 2 secant of 2x minus pi over 2. We can change that into the cosine to get our guide. Factor out your 2. And we are going to use that as our guide. So we have a shift pi over 4 again, and a period of pi, just pi. So we're shifting right pi over 4, so I'll count by fourths again, and then I have 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So our cosine graph is going to start with an amplitude of 2. We'll do this time. So pi over 4 starting with an amplitude of 2. It's ending pi units later, which is 1 pi over 4, 2, 3, 4 pi over 4. So 4 pi over 4 after 1 pi over 4 would be 5 pi over 4. Get your minimum in there. Halfway in between your zeros. Here's your guide. Throw your asymptotes in. Follow?
Yeah.
And then reflect. And there's just one piece, but we could kind of continue our guide to get a few more in there. Yep. Other questions? No? Okay. On your paper right now, I want you, just as a practice, I want you to do this one. Y equals 2 secant of x plus pi over 2 on your own. So take a minute to do that. Adam, pick two numbers between 1 and 25.
17.
No, I'm just gonna raise your hand if you're done. Is it?
Yeah.
What's wrong? Are you not confident?
No, I'm not.
Okay. So, we first have this one. So let's take a minute to think about that and what kind of critique we would have to offer this one. Thank you. As soon as you see something, raise your hand. Something that you would comment on. We're going to have a nice little discussion here. Steven? Okay. So she took her cosine curve that had an amplitude of 2, and she moved it left pi over 2 units. Okay. She has zeros here and here, so she drew in asymptotes. All good. And then she bounced in the middle of those asymptotes. So there's her bottom portion. If you were going to do one full period's worth, you should also kind of do that and that on either side. Does that make sense? Okay, so let's just say for the sake of this, we'll do one full period of whatever it is that we're doing. So that would be one full period. And that's all good? So everyone, I agree, it is good. Everyone should have a critical point at pi over 2, negative 2, should be a maximum. Asymptotes at 0 and pi. And then a critical point at negative pi over 2, 2, and 3 pi over 2, 2. Good? Any questions at all on that? Okay, so let's see what we have. Do you know why, Taylor? You didn't draw the guide, and, well, it looks like you had something in there. So, you think you made this mistake because you didn't draw the guide? Okay, go up to the board and redraw your guide. You don't know where it goes? Because why? Because you're not good at graphing just plain cosine functions? It's a cosine parent graph shifted. So on the, well, I'll let you go. On the right side in that space below, can you just draw one cycle of a positive cosine curve? Not on the graph at all, but over in that blank space, like over here. Yeah. Right. So now, shift that pi over 2 units to the left. Okay, so hold on, we're right there for 1 second. I think the reason that's tougher, and Jalen, this is what you and I were talking about yesterday. I think it was you. Is that I think it's harder when you guys try to do these points sequentially from left to right, rather than focusing on, okay, my cosine curve needs to start here. Where is it going to end? So rather than going left to right, start with this point and then figure out where this point is going to be, right, which is 1 period later. So if we started at negative pi over 2, and we're adding on 1 full period, which was 2 pi, at what x coordinate is this cycle going to end? 3 pi over 2, so this is negative 1 pi over 2 plus 4 pi over 2 is 3 pi over 2, which would be here. And start there, and then go halfway in between those points down to your minimum. Yes? Does that make it easier? It was you, right? You were trying to do exactly what I just watched Taylor do. She's trying to get the left point, then the next point, and that can work if you split your period up into 4, right? And then count by that much to get to each sequential point. But I think it's so much easier if you just have the start of your cycle, the end of your cycle, and then going halfway in between to get your minimum, and then halfway in between your max and min to get your 0. Yes? Okay, so maybe that can help more of you if you kind of like Taylor and like Jalen were doing your graph in that way. Then from here we bounce, which is why over there, so now we look the same as Lizzie does it too. Okay? Any questions on that? Okay. Let me give you a little try. Go to your next blank graph. And there's going to be some brainstorming. Can you pass this back to Taylor, please? I want you to try y equals the absolute, secant of the absolute value of x. So, you've never seen anything like this, but I want you to brainstorm, and I want to see what we come up with. Me included. I'm also going to brainstorm because I'm going to think about this. This should be a bonus.
I got it.
I think I should redo this.
Yeah, I don't
Oh,
think
you're-
it's that bad. But I'm probably wrong.
Really?
I thought it was easy, so I'm probably wrong.
Well, you guys.
Yeah, it's pretty easy actually.
I graphed 2 circles if it was that okay, or it should just be 1.
I'm not confident yet. Hold on. Who wants to? Who wants to? Oh, really?
I think I want more than everyone else.
I did. I really do. This is my redeeming moment after all those bad graphs.
Liam,
Wait, actually?
pass yours over. Here's what mine looks like, and I'm not confident yet. Not?
Okay.
So,
Because I was thinking that.
and this is what, oh, Liam's looks just like mine.
I didn't go into the negative because I was thinking that it wouldn't.
Yeah.
He was thinking, okay, good conversation point to start with. He was thinking you can't graph negative x's.
But then
Why not?
I just realized that it would still be the same, like you had it because.
It's actually going to be symmetrical to the y-axis because you can plug in positive x's or negative x's and you're going to get the same output regardless. So there is symmetry with the y-axis, but other than that, his looks the same as mine.
Maybe you guys are wrong.
So, Liam, tell me why, this is good discussion, Liam, tell me why you came up with that and why so quickly, because I have a boatload more work.
Just because.
Other than you're just flat out smarter than me, but that's okay.
Because like.
I don't know.
Any x value has to be. Well, I was thinking that it had to be positive, but I realized that's wrong. But it's just like a regular graph, like a regular.
You have to flip it up because it's absolute value. So that point at the bottom.
Yeah, but it's not, whoa. You're thinking of this, Jalen. You're thinking if it was this. Which is kind of what I figured a lot of you might do.
Pretty sure that's what everyone
Because, and this is where you guys are just creatures of, I want a rule and I want to follow a rule. I don't want to have to think about anything. When we have seen absolute values in the past, it has been around the whole function. So you do just draw y equals secant x in this case and flip up all the negatives. That's what you've seen in the past, but that's not what this one is. Liam is correct. This is, and so I didn't even think of it as simply as Liam did, but Liam simplifies the whole process. It's just the secant of x graph, which is going to be the same as this, with the exception of when we plug in negative x's, we're going to get back the same thing, which actually with the parent secant graph we do anyway, right? So he was thinking about the absolute value, yes, but it actually does nothing to the graph. It is just the parent graph. So I was a little suspicious about the absolute value. I was like, I'm not sure the cosine of x really can be my guide here. Can it? Did anyone graph the cosine?
Because I have the same thing, otherwise I just flipped it up. With the cosine of x makes it work, because otherwise mine looks the same.
So
I actually have something else.
I had that point at pi. I had it up at a maximum, and then
right, you just flipped everything.
yeah.
Yeah.
But my other points were the same. So the graph of cosine of x works.
Well, what I'm saying is, does the graph of the cosine of absolute value of x work as a guide? That's what I'm curious
That's what I'm
of.
thinking because.
So I'll cheat and use the calculator for a minute. If I were to graph the cosine of the absolute value of x and use this as my guide. So I just got to make my window 0 to 2 pi, negative 5 to 5 will do. Make sure our mode is in radians. We're good. So will this, so again, the absolute value does nothing to the cosine curve, right? How do we make sense of that? Why doesn't it do anything? It's got to come back to all students take calculus somehow. Well, that's the absolute value of the cosine graph, which is why, yes, that can work as a guide, as we've seen, and it just gives you the regular sine graph. So why? So the question is, why is the cosine of x always equal to the cosine of the absolute value of x? Because it's an even function and symmetrical to the y-axis. Good.
That's what I was thinking. Because if you plug in a negative pi, so cosine negative pi equals
So you can still plug it in. You're not getting an undefined. So if I'm dealing with this function, why can't I have an x-coordinate of negative pi? You can. Right, it's just going to equal the same value as the cosine of positive pi. Do you follow, Josh? Okay, which would be negative 1. Very fun. Good combo. So here's what your homework is going to be. Let's do, what did we do last night? 3s, 5s, and 7s? Let's just do the same sections, 1s and 9s. Same sections, just 1s and 9s, so we'll have done all the odds. We'll have another day of practicing and wrapping our head around all this. So for the record, you are going to get to a couple of absolute value ones, which will be good. The same as last night. 1s and 9s. I got to pull out yesterday's notes to see. Page 532. My head hurts. Does your head hurt? I thought too hard today. No. I told you that would be fun.
My head hurts.
I knew it would be fun.